Kia ora Year 12 and Year 11. Here's another question from the November 2015 AS paper. This is Pure 1, and this question is a really nice one with some function stuff in it. So it's got three parts to it. We're given a function, and the function is a pretty general quadratic, and a and b are constants. And in the three parts of the question, what we assume about a and b changes. So the first one is pretty straightforward. When a is 6 and b is -8, we have to find the range of the function. And in the next one, we're told that a is 5, and we're given the roots of the equation. So they're the roots of the equation f of x is equal to 0, and they're k and -2k. We have to find the values of b and k. And in the last one, we have to show that if this equation has no real roots, then this is true. So as soon as you see that last one, you should be thinking that it's something to do with the discriminant, and that if we've got no real roots, the discriminant is strictly negative. So let's just work through these. Okay, so in the first one, a is 6 and b is -8. So we can write the function f of x as x squared plus 6x. Take away 8. And if we want to find the range, the easiest way to do that is to complete the square, because that's going to let me see I've got a up the right way parabola, could be sitting anywhere, but if we can find it in vertex form, then we can easily see the range. So let's complete the square on it. Well, we get x plus 3 squared. We've added a 9, so we take out the 9, minus 8. Now, if you're not familiar with my way of doing that, go find my level 2 algebra video on completing the square. And you may well have your own way of completing the square, but I like this one. So now we've got y is equal to this squared thing, take away 17. So that means the lowest possible value here is 0. And that means that here, the range is that the function can take on any value that is greater than or equal to -17. Right, because this bit here is never going to give me a number lower than 0. And then I take 17 away from that. So that's the first bit done. Okay, let's look at this next one. If a is equal to 5, then we're told that the roots of f of x equals 0 are k and -2k, and k is a constant. We have to work out what b is and what k is. So the first thing we know is that this time y is equal to x squared plus 5x plus b. Now the roots are k and -2k for the equation y is equal to 0. There are some different ways to do this, but by far the easiest way, I think, is just to say, well, we've got an x squared thing, and we know the roots are k and -2k for this equation, so we can write the equation like this, because that's what it means for k to be a root. And all we have to do now is to say that we've got two ways to write this equation. We've got this way, using the roots, and we've got this way in expanded form. So if we expand this out, we get x squared plus kx minus 2k squared is equal to 0, and x squared plus 5x plus b is equal to 0. So we can just match up those coefficients. 5 must equal k, and b must equal -2k squared, right? So I'm matching up this with this. That means that b is equal to -2 times 5 squared, which is -50. Now the other way that you can do that pretty quickly is by using what we know about the sum and product of the roots. Right, so we could do, I'm going to do it this way as well now. The roots are k and -2k. So we know that the sum of the roots is equal to -b over a. So here's x squared plus 5x plus b. So k minus 2k is equal to -5 over 1. K is equal to -5, giving me k is equal to 5. And we know that the product of the roots is equal to c over a. So we get -2k squared is equal to b. And -2 times 25 is equal to b. So b is equal to negative 50. So it's great if you're confident with that, but most students prefer, I think, to use the direct definition of what the root of an equation is. But if you're watching this and you're doing level 2 algebra, you might have done some problems this year where you used the sum and the product of the roots, some harder problems. Okay, so 2 ways to do that one. Let's look at the last one. Okay, so show that if this equation has no real roots, then this condition must hold. Right, so for this one, remember we're going back to f of x is equal to x squared plus ax plus b. But we're told that this equation, f of x plus a equals a, has no real roots. So what's f of x plus a? Well, that means that instead of putting x into my function machine, I put in x plus a. And I get x plus a squared plus a times x plus a plus b. And I want to set that equal to 0. And then we're going to manipulate this. So if it's got no real roots, what we're trying to find is the discriminant for this equation. So let's expand it out and see what happens. We get x squared plus 2ax plus a squared plus ax plus a squared plus b minus a is equal to 0. We want to collect up like terms and then find the discriminant. So we've got 2ax here and ax here, and we've got an a squared here and an a squared here, and these two bits. So we've got 2a squared plus b minus a is equal to 0. So then we need to explain what we're doing. For no real roots, the discriminant, and I'm going to put that in silly inverted commas because the b and the a in here are not the a and the b in here. So that must be, the discriminant must be strictly negative if we've got no real roots. So here, b squared minus 4ac is equal to 3a squared minus 4 times 1 times 2a squared plus b minus 0. That gives us 9a squared minus 8a squared minus 4b plus 4a. So my discriminant is a squared minus 4b plus 4a, and that has to be negative for no real roots. What do I get now? Well, I'm nearly there. I've got a squared is less than 4b minus 4a, giving me the condition that we're after. A squared is strictly less than 4 times b minus a as required. So there we go. I'll just see if I've got the examiner's report for that one. No, I haven't got that handy. Okay, so let's go back to the top and just have a look for things to go over. I think probably the places that people went wrong in this, I think the first bit's pretty straightforward. But in here, if you start trying to solve this by saying if it's a root of an equation and f of x equals 0, then you're going to go wrong. So one thing you could do here is go k squared plus ak plus b equals 0, and then do the same with negative 2k. And I think if you go down that pathway, the chances that you get all the way through to the end to find b and k are pretty low. So you have to have firmly in your brain for AS the idea of what the root of this equation equaling 0 means. Okay, and in this one here, you have to know that f of x plus a means to take x plus a and to substitute that in for where x is. You also have to recognize properties of discriminants. Alright, that's all I'm going to do in this video. I think that question covers off a lot of good level 2 algebra content as well. So if you're watching this and you're in 12 MCA, make sure that you are really on top of the skills in this question.